Pre-calculus, welcome back. Here's section, oops, I forgot to change it up here. This is section 1.7.1 notes. We're going to talk about inverse functions. And the first way we're going to talk about them is the concept of a horizontal line test. So the horizontal line test we mentioned a couple of days ago, and I said you didn't have to worry about it just then, but we do have to worry about it now. Because it's going to tell us whether our function that we have has an inverse. So if it passes the horizontal line test, let's remember, what is a vertical line test? Remember, if we have a graph that looks something like this, and we do vertical lines through it, and we only cross the graph one time, then our graph is a function. Well, likewise, if we take that same graph, and we draw horizontal lines through it, if we cross the graph more than once with our horizontal lines, then it means we don't have an inverse. Or if we're going to have an inverse of it, because you might be going, but Ms. Harris, I thought the square root function was the inverse of the quadratic function. It kind of is, but the way that we make it work is we get rid of this piece of our domain of the quadratic function so that our square root function, right, when we flip that across, it looks like this, something like that. And then because we restricted the domain, now we've got a square root function that works. And that's why we have those domain restrictors that we've been talking about in class. So if we take half of a parabola, that is an inverse, and its inverse is the square root function. So again, the whole point of the horizontal line test just says that if you can draw a horizontal line anywhere on a function and you only cross that graph one time, then it has an inverse. We're not finding the inverse just right now. The horizontal line test tells us whether it has an inverse or not. And we've kind of talked about this example, so I'm going to move on down here. Now we want to graph these things. Our first one is the graph of absolute value of x minus 1. So coming back over here to Desmos, getting rid of this calculus problem. And we want the absolute value, where did it go? Here's absolute value of x minus 1. Will this guy pass the horizontal line test? Well, we see it's a V shape, which is kind of what we expected from an absolute value. This is the shape of my graph. Does this guy pass the horizontal line test? No, it does not. No, which means this guy here, this function f of x, does not have an inverse. All right, let's look at B. B is a cubic function. Cubic functions, sometimes they have an inverse, sometimes they don't. It depends on whether our cubic function looks like this. That would pass a horizontal line test, right? Or whether our cubic function does something like that. Would that one pass the horizontal line test? No, right? Because now when I go here, I've got 3 different times where we cross that guy. So let's see what we have going on. We've got x cubed minus 6x squared. Back over here to Desmos. I want x cubed minus 6x squared, and then plus 12x minus 8. Oops, got 2 minuses there. Minus 8. And this one looks like it's just a nice, real pretty cubic, nothing special happening. We can zoom in real close to that 0, see if anything's happening there. Does not appear to be. So this one looks like it would qualify to have an inverse function. All right, so an inverse exists for B, but did not exist for A because it didn't pass the horizontal line test. Go ahead and pause the video. You can think about what you know about these kinds of graphs to determine whether you think it would have one or not, and then we can go look at Desmos and test it for sure. All right, if you're coming back, hopefully you paused your video and thought about it. This guy here, h of x, is a rational function, so I'm thinking it's going to look something similar to this. So my guess is yes. And for x squared plus 5x minus 7, it's going to have a parabola shape of some sort, so I'm going to say no. But let's go check these guys out in Desmos. So 4 over x. We look at that up here. 4 divided by x. Ooh, we are zoomed in, but if we zoom out, yep, this guy would pass. Now it looks like this guy gets really flat right here, but if you take your cursor and you move along, Notice those y's are changing. We never repeat the same y. It's getting closer and closer to what on each slide? Here it says getting closer and closer to that asymptote, which is there at 0, but it constantly changes. So we were right about that rational function. That one would have an inverse because it does pass the horizontal line test. And then our other guy was x squared plus 5x minus 7. So x squared plus 5x minus 7. This guy is very much a regular parabola, which does not pass the horizontal line test. We can see that just right here. We have two x's with the same y. So it doesn't pass the horizontal line test, therefore it does not have an inverse. And so that's all the horizontal line tells us, is whether it has an inverse or not. In our next video, we're going to talk about how we can find an equation for that inverse.